All right, hope everyone had a good weekend. We're starting off with 6.04 polar graphs and distance formula today. Pretty short, shouldn't take long to get through this. Pretty basic here. So in the past, well, last week, I taught you about polar coordinates being in the form of r and theta. Well, today we're just going to split it up. And we're going to graph either r or theta, and then we'll talk about distance formula here shortly. Okay, so remember, r is represented by the ring. So when it says r of 2, we're just going to go from the origin here up 1, 2, and we're going to trace that whole ring. And there you go. That is r of 2. Okay? Negative 4, negative doesn't change it whatsoever. Same process. We're going to start the origin. We're going to go up 1, 2, 3, 4. And trace that, and there you go. That is r of negative 4. Okay. All right, theta equals pi over 6. So now we're going to look at the degree measure instead of the radius of r. So again, first thing I want to do is I want to multiply that by 180 over pi. And so when I do that, it's going to give me 30 degrees, okay? And so my next choice, my next option then, or the next thing I do, not option, is I go to the 30-degree spoke, which is going to be right here, okay? I start up here and I go all the way through the origin. I trace the whole spoke on the polar plane. And at the end of each spoke, I just draw arrows there because this is a continuous line. So if we had like r of 1 million, it would continue to go throughout that whole polar graph. Okay, no matter how big it is, just continuous. All right. Again, whenever you have a positive angle, you go counterclockwise. And so we went that way from standard position right here. Okay. 225, same thing. We start from standard position. It is positive. So we're going to go counterclockwise that way. And so I go 90, 180, 210, 225 right here. Again, I'm going to trace over that spoke. And I'll draw arrows at the end. And there you go. So that's the graphing part. Now, guys, I know that seems really easy. It does not get any more difficult than that. But please pay attention to that. I've had students miss it multiple times on this quiz coming up. Okay? Second section here, distance between points. Okay, now, I apologize. This picture is not the exact picture of this first question here. Okay, but this is kind of what I'm expecting of you, right? So on the quiz, I'm going to have you graph both points and then connect a line in between. And so that's kind of what is going on here. Okay? So thing you need to understand is that this is your distance formula right here. Okay? It is a formula that is on your formula sheet on the back of the calendar, so please make sure you have access to that for the quiz come Thursday. Okay? So we're going to be given two polar coordinate points. We're going to label the first point r1 theta 1, the second point r2 theta 2, and then we're just going to plug it into our formula to find the distance. Okay? So before I start this problem, I'm going to label this first point 8 r1, the 150 theta 1, the 3 is r2, the 65 degrees theta 2. Okay? And so now what we're going to do is we're going to go ahead and we're just going to use our formula here, plug it into our formula. So we're going to get this. We're going to get the square root of r1 squared, so 8 squared, plus r2, 3 squared, minus 2, r1, 8, r2, 3, and then cosine. Make sure, very important here, theta 2 always goes first. Theta 2 minus theta 1, so theta 2 is 65 degrees, minus theta 1, which is 150 degrees. Make sure this is all under the square root. Okay. Now what we're going to do is we're going to use our calculator to plug it in. So you can go square root, 8 squared, plus 3 squared, minus 2, open parentheses, 8, close parentheses, open parentheses, 3, close parentheses, and then we go cosine 65 minus 150. Make sure you close it, hit enter, and if you did it correct, you should get 8.3. I just put a U there for units because it didn't give me the exact one. Okay. All right, an air traffic controller is tracking two airplanes that are flying at the same altitude. The coordinates of the planes are A, 5,310, and B, 6,345, where the directed distance is measured in miles. find the distance between the two planes. So this time again, first point, so R1, theta 1, R2, theta 2. I'm not going to label them out for you this time. I think you guys are capable of doing that. Just going to go ahead and let's find the distance between the two planes. So R1 is 5, so 5 squared. R2 is 6. 6 squared minus 2 times R1, which is 5. R2, which is 6. Cosine of 60, not 65, I'm sorry, I'm looking at the last problem. So theta 2, which is 345, minus theta 1, which is 310. I showed it on the first problem, how to plug it in the calculator, so I'm just going to skip that. If you did it correctly, you should have got 3.44, or in this case, we're just going to round the tenths. So we're going to say 3.4, and we're going to label it miles, because it actually gave me a unit this time. So please do not forget your unit. All right, that's it. Pretty short lesson today, like I said. Well, to some of you guys that already had class. All right, but yeah, short lesson today. Make sure you're watching the video, going over this, working on the homework. All right, that'll be it. I'll talk to you guys tomorrow. Thanks. Peace.